We again are in section 4.1, and today we're going to discuss coterminal angles. Before we get into what a coterminal angle is, I want to kind of go back over graphing again just one more time. So for our first example, we're going to graph an angle of a negative 8 pi over 3. So again, we start with 0, and then on the left-hand side, we pick whatever our denominator is. So in this case, it's a 3. So this will be a negative 3 pi over 3. And then we figure out what's halfway between 0 and 3. So this one's a decimal. It doesn't work out as nice, but the concept is the same. I can say this is a negative 1.5 pi over 3. And now each time we go by negative 1.5s. So at the top, this will be a negative 4.5 pi over 3. The next one will be a negative 6 pi over 3. So notice we haven't hit a negative 8 pi over 3, so we need to keep going. This is something we did not discuss yesterday. So if I keep going, a negative 8 pi, I'm at a negative 6 pi over 3, I add a negative 1.5, I'm at a negative 7.5 pi over 3. And over here, this would be a negative 9 pi over 3. So at this point, we can now stop because we can figure out where the angle would be. So our initial side is right here, and our terminal side is going to be in the third quadrant. So between a negative 7.5 and a 9, the 8 is going to be closer to the negative 7.5. And I want you to just watch the video for a second. Don't just pause on drawing anything. So I start on the initial side. Since it's negative, I go clockwise. So notice I'm going to go in the clockwise direction. And I go around, and I want one full time around, and then some. So that's like a new part from yesterday, is that we can go over a full revolution. So you were always told that you can't have angles that are larger than 360 degrees. Well, now that you're getting to a higher level of math, there can be angles that are higher than 360 degrees. So this is how you graph one that would be larger than 360 degrees. So now this kind of brings into the idea of what we call a coterminal angle. So a coterminal angle is that when these angles fall in the same spot, and what separates them is a revolution. So this angle right here would probably be a negative 2 pi over 3. So if I were to graph a negative 2 pi over 3, the picture would look almost the same, except the only thing that would be different is the revolution. So the revolution would just be this piece right here. So that's what a coterminal angle is. So we're going to go ahead and take a moment and write that formal definition in our notes. So a coterminal angle, oh geez, got sloppy there. A coterminal angle is when angles lie at the same spot (360 degrees) or 2 pi apart. And you can either add or subtract 360, or add or subtract 2 pi, depending if you're in degrees or radians. And all that means is that I could go in the positive direction or in the negative direction, and I could go around and around and around. So just an example on this. So the directions are going to say find a coterminal angle. So find a coterminal angle that is positive and less than 360 degrees or 2 pi. Now remember, coterminal angles, there's infinite many coterminal angles. This direction that they're giving you is specifying what specific coterminal angle they are looking for. So let's say that the first angle that is given is 470 degrees. And I want to know a coterminal angle, so I want to know another angle that would fall in the same spot. So we need to essentially either add or subtract a revolution. So because the directions say my final answer needs to be less than 360, that means I'm going to subtract 360 from this. So I'm taking out 360. So that means 110 degrees would fall in the same spot as 470 degrees. Example 2, I have a negative 120 degrees, and I want a positive coterminal angle that's less than 360. So right now my angle is less than 360. However, it's not positive. So now I'm going to be adding 360. So a positive 240 degrees would fall in the same spot as a negative 120. So that's how you do this in degrees. So keep the same directions and just kind of build off of this problem. So I'm going to put number 3 and 4 on the next page. They're just going to be radians. So number 3 is a 17 pi over 6. So notice now we're in radians. So I'm not dealing with 360, I'm dealing with 2 pi. So I need to subtract 2 pi. However, in order to subtract these, I need to have common denominators. So I need to multiply this by the denominator of the other fraction. So I have a 6, so I need to multiply this by 6 top and bottom. So I'm dealing with 17 pi over 6 minus a 12 pi over 6. Now 12 pi over 6 is equal to 2 pi over 1. So that's kind of your cutoff. My final answer needs to be less than 12 pi over 6. So when I subtract these, I get 5 pi over 6. So this angle is positive, and it's less than 2 pi. So I do not need to go any farther. Number 4, I have a negative pi over 12. So notice this angle is negative, so that means I need to add 2 pi. And this time, because the denominator is 12, that means I need to times by 12, top and bottom. So that will always change depending on the problem. So I have a negative pi over 12, and I'm adding a 24 pi over 12. And when I add these together, I get 23 pi over 12. So notice my angle is positive, and it's less than 2 pi, so I've met the criteria. So that's all for today.